Better? Huh? Yeah, I mean, the funny thing is the ones that are most needed are ones we've already done. So I'm like, I don't know why they don't go find those and take them out, but they'll come up, right? I don't know, we could ask them. Are you guys trying to find the topics that we do as notes? Or are you just not stressing about it?
Do your homework, but then you have your normal topic. Right. And then you said, go in there and you said, let me find color is.
This one is like maroon.
No, it's like what color is
super dark purple.
Super dark purple.
And I didn't even know how to find them.
Okay, so finding them's hard?
Yeah, you might be able to describe.
Okay.
Go to like a certain topic with like a pie slice.
So we're so used to just kind of doing whatever they tell us to do that we just don't jump to those. Okay. And honestly, some of you don't have them yet. I pick ones that most of you have or will eventually have. Okay. I think, Mason, didn't I help you with these ones? Okay, do you remember them? So, go ahead. Okay. Yeah. So here's the weird thing about this is when you have the radical and whatever's right here, and I don't care what I have here, triangle, if these two things are the same, and if I want to put numbers in there, I can. Those are both 7s. Then those things cancel each other out, and the answer is just triangle. Okay. So then that first one, the 5s cancel out, and the second one, the 4s cancel out. But there's a trick. So the answer to A is X, and the answer to B is 5Y plus 7. That's why Miss H was like, really, we're doing this? Okay, because every single one, they're going to do that, where they're just going to have those match. They want you to see that this happens. But there's a catch. I'm going to tell you what the catch is. The catch is that this one has absolute value, this one doesn't. Tell me why. What do you notice is different between the first and the second? Okay, so good. The second one has an equation. That's not the reason why it has absolute value. It's a good observation. What else is different about them? Huh?
If it's negative number, times by an even, by itself, even amount of times it.
Okay, good. So he's saying this number here is 5. It's odd. So if I put a negative number in here, it can give me a negative answer. But this one is even. If I get a negative out of there, a negative raised to an even power is going to be an even number of negatives. A negative and negative does what? Negative times a negative.
Positive.
Becomes a positive. So if I have 2 negatives, I end up with what? What if I add 2 more? Now I have a positive. This becomes a positive. This becomes a positive. So what do I have? Positive. What if I had 2 more? What if I had 2 more? What if I had 2 more, right? So no matter how many 2 mores I add, now here's where it gets weird. If I have 4, it's a positive. But as soon as I add 1 more, it's a negative, right? So this thumb, if we could cut the thumb off, I'll cut my thumb off. This is what makes it negative. Okay? So I could change these numbers. I could change this to 7 and 7, 15 and 15. As long as these are odd, this answer is the same. If I change this to an even number, then it has absolute values. Make sense? Okay. Any questions about that? Let's just look at one more. Might as well. They're super quick. You don't even have to write this down if you don't want to. What's the answer to A? What's the answer to B? Awesome. Yeah, this is the one that gets the absolute value. Good. Can we leave this? We good, Miss H? We jump down to evaluating.
Not everybody's like different. Not teaching you exact problems, it's teaching you how to solve a problem.
That makes no
like
sense.
this.
This makes no sense. How would that make?
Thank you, Miss H.
I wasn't even talking to you, boy.
You're talking about me.
No, I actually wasn't.
So write this down. So we have this function, and then we have these numbers.
I already did this. You good. Oh, heck yeah, I already did this.
So first off, when we do problems that have radicals, a lot of times we kind of hope that they work out. We hope that they can put them in the calculator. Miss H likes to tell her students, and I need to take this advice for some of my students. She says, if you can put it in the calculator, what should you do? You should put it in the calculator. Can you put these in the calculator? And if they work out, then life's good, right? So this notation, I don't know, I assume we know this, but this means plug that in there. So that f of negative 61 means go to third root, and instead of writing x, I'm going to write negative 61 minus 3. So here's the $1,000,000 question. Do we know how to put that in the calculator? You hit the math button, and you should see an option that says third root of whatever you want to put in there. And then you can type that exactly as I wrote it down. If it gives us a crazy ugly decimal, then we have to do some work with it. If it gives us a nice number, then we just write down, what did it give you? Negative 4?
Yeah.
So we just say negative 4. If it had not given us negative 4, we would have combined negative 61 and negative 3, and then broken it down and figured out what we could pull out. And I have a feeling that that might show up today. I actually don't know. Can you tell me what the second one is? 5. So I try it first in the calculator. Spits out an answer. Boom, we're done. Okay. Another easy peasy strawberry lemonade problem, right? Okay. Are we goodish? So smart.
What I'm doing.
Mm-hmm. I mean, not exactly what I want, but you know, work smarter, not harder. All right, ready for the next one?
Yeah.
We're going right down the list, right? So it should be domain. What'd I do? Did I do something different? Show me after lunch, okay?
No, look, there's squares. Like this is how you put it in last week.
Mm-hmm.
And you went and did
Oh,
it.
yeah, that was a mistake.
Threw me off.
Sorry. I should be fired.
Yep, you should.
All right, so domain. Domain means what numbers are we allowed to put in? Okay, what numbers for x are we allowed to put in? Now, what do you notice is different between F and G? F is odd. So that's what the deal is here, is that this is odd and then this is even. Do me a favor, and in your calculator, do third root of a negative, 0, and a positive. Any random one. Just go to your calculator, do math, negative, 0, and positive. Just, I want you to get any number. Just do third root of any negative, third root of 0, and third root of any positive. Then I want you to do the fourth root of a negative, 0, and a positive. Any number. And then I want you to tell me which ones work and which ones did not work. So do third root of any negative, third root of 0, third root of any positive. Then do fourth root of any negative, fourth root of 0, fourth root of any positive. So third root, I'm sure you're understanding what I'm saying. Third root of, give me any negative number. Then do third root of 0, then third root of any positive number, and then do the same with fourth root. What do we notice with third roots? Which one doesn't work? Good question. Brandon, what did you notice? Okay. Did you get an error anywhere else? Okay. Did anyone, so how about a third root of a negative? Did you get an error here? Tell me where we got an error. Did we only get one error? Hello? Is that bad dream I have? Okay. So we get this one work, this one work, this one work, this one should work, this one should work, and this one, I'm going to change color because I'm not sophisticated, is the error. So you're allowed to put any number you want into a third root, a negative, 0, or positive. And if we kept playing this game, we could put fractions in there, we could put decimals in there, anything would work. In the fourth root, we put anything we want that's 0 or positive. Okay? We're not allowed to have negative numbers under the fourth root. Now, let's talk about that. So looking at this first one, that means what's true about it? What numbers are we allowed to put in? I'm making good connections, right? Am I doing it? Okay. So what I'm getting at is for third root, what numbers work? All of them. All of them. So interval notation means what's the smallest number you can put in? What's the smallest negative? Negative infinity. What's the biggest number we can put in? Positive infinity. So that's how we say all of them in interval notation. The next question, we know that we can't have what? Can't have negative numbers. So here's the question. We can have 0 and we can have positives. Okay? So my first thought with what I just said is that, and I like what you said, 0 to infinity, but that's wrong. What's wrong about that? Super close. If this was a test, I'd go, I'm going to give you half credit. I would. I'd be like, oh, man, they missed this one little part. So if I plug in 0 into this thing, what do I get under here? If I plug in 0, what happens to that 0? It's added 2. This is tough. 0 plus 2 is 2, right? So, yes, thank you. So what number would make this negative? What number would make this 0? -2. Are we allowed to have a 0?
No.
Yes. So -2 is the cutoff. Awesome. I can't tell if they're getting it or asleep or too much partying over the weekend. Maybe we need to do these on like Wednesdays. Okay. So -2 plus 2 is 0. As soon as I go lower than -2, if I put in -3 plus 2, I'm going to get -1. Okay. So basically I'm looking for what gives me 0, and I know anything greater than that's going to be fine. Make sense? Those are hard to read today too. It's like when you break up and you say it's not me, it's you. Is that what you do?
It is.
Oh.
Yeah. The financial book for next year, is it around?
Yes.
That's okay. I don't mean to interrupt.
Okay. It's all right. I'll get it to you as soon as I have a chance. You're fine. All right. Domains. So now graphing. Yes, except it might not be the same anymore.
Should it be a bracket?
Should have been bracket. Absolutely. Yes, it should be a bracket. I'm sorry. Yes, because it includes that. Because 0 is okay. Thank you for clarification. This one, look, let's just look. Okay, so the bottom one, watch. That's the bottom one.
Oh, never mind. Homework is like that, but it's has 4.
Right, so she's saying, what if I have the 4th root of 2x plus 8? Okay, so how do we do that one?
It's 2.
Well, I know that it goes up to infinity. Now, positives I'm okay with. The question is, when is it 0? When is it 0? So when it's 0 is like the point from 0 is okay in this way. Anything lower is bad. So what I'm going to do is I'm going to take this out, and I can just set this equal to 0 to find that special other number. So I'd say I would minus 8, 2x equals -8, divide by 2, x equals -4. And as Mason pointed out, which I made a mistake on, that absolutely needs to be a bracket because 0 is okay. If we said that 0 wasn't okay, we'd say parenthesis, but 0 is okay. So for the 4th root ones or even root ones, we got to just take that out and figure out when it's 0 and then say anything greater than that's fine. Okay? What could I have done?
When you were doing that, you could just say you pull up this and then you go to 0 and then you solve it.
I know, but
But you did this and then you took it in a.
it's like I wanted you to think and like understand. No.
Do the next
Okay, thank you.
one.
I really appreciate your input.
You're welcome.
Graphing a square root function. Yeah. right? So when are you not allowed to use your calculator? When you were in red, I guess.
Yeah.
Those days are long past. So
This one is, you have to have the tip. They do this, the hard, what's in
Oh, yeah.
past that.
It's not like the
Or
other.
like when they graph it and they have to have a center point, 2 on this side and 2 on this side.
so
Like the other graph.
you can, so one thing that I want to point out to you is that when using the ALEKS program and graphing, because if I was teaching this in regular algebra 2 and you were writing the answer down, and we probably did this last year, first of all, the number under here, when that's 0, is important. So when is that 0? 1, okay? So at 1, this thing is 0. This is how I would have taught you last year. Does anyone remember the shape of this graph? Okay, it looks like you're shooting off a rocket. Last year, that's what I would have asked you to do on the test. Boom, we're done. ALEKS makes you do a little bit more. ALEKS makes you do a little bit more in terms of graphing. You have, and my favorite thing, and I think the notation, it looks something like this. There's a button that looks like that. Or maybe I have those backwards. When we click on that button, it lets us put in an ordered pair. So one thing is that it's going to require you to do is to put the leftmost point in. How do you find that leftmost point? The leftmost point is the point when the thing under here equals 0. Okay? So that's going to be your leftmost point. So you need to have, so when I put in my ordered pairs, when I click on this button, is that what this button looks like? I'm pretty sure it looks like that. Anyways, you click on that and it's going to say what's your ordered pair. We'd say 1, 0. Okay, and then we got to plug in a couple more numbers. 2, this says we need 3 additional. So it doesn't matter what numbers we plug in as long as they're nice. 2 gives me 1. How could you find this out? I don't want you to hurt yourself thinking. Put in the calculator and look at the table and just find nice ordered pairs. The only thing that's important is that you have to have this one right here. You have to have the one that gives you 0. Okay? So 3 is going to give me ugly decimal. 4 is going to give me ugly decimal. 5 is going to give me 2. You just plot that one. Okay. We need one more. 6 is going to be ugly. 7, 8, 9, 10. 10 is going to give me 3. You put those points in, and then you click on the button that says connect the dots, boop, and you're done. But that leftmost point is the most important. There's some common themes that are showing up here. That knowing when 0 is underneath the radical, okay, and also knowing how to handle if you have a positive or an even or an odd root. I don't know whether this is going to possibly give you any odds. I don't think so. Okay. Oh yeah, square root function. Okay. So these will all look the same. So let's not do this one, but talk about it for like 10 seconds. So here I would find when this gives me 0, which would be -3. And then I would put in the calculator, and I would look at my table, and I would just pick out nice points. Okay? Anyone not know how to do those steps? Calculator, we know how to look at the table. Okay. We have one left. So these are funny because they've almost painted themselves in a corner on how to have you do these. look at what they say. They say plot one point that makes this thing equal to 0, because they're saying you got to know that one point. If you didn't know the difference between a third root and a square root, so for half a second, let's pretend like this is a square root. What, first off, we would ask is what makes this 0? Well, that's a weird question. If it's just an x under there, then 0 makes it 0. And if I plug in 0 there, then the answer is 7. Okay? So that weird left point is 0, 7. So we have our table, and one of our points is going to be 0, 7. And if this was algebra 2, and we're just drawing this thing, we would go like this, and we would be done. If it was a square root. Anybody know the difference between a square root and a cube root in the terms of its graph? The only difference is that cube roots have tails. So in algebra 2, all you had to know was treat it exactly the same. And if I just asked you to sketch it, boom, there you go. Alex is going to ask us to give us this point here, which is called an inflection point in calculus. Okay, it's where it kind of turns from curving one way to curving the other. And you always find that, and it tells you what to do. And then it says plot 2 points to the left, 2 points to the right. So let's go ahead and type this in our calculator. And then just tell me what points I would put on my table here. Do it. Y equals. And that's where we're going to put the equation. Third root of x minus 7. And then we're going to go to our table, so blue button table. And then we're going to look here, and you're going to give me nice numbers. Okay. So looking at our table, we already decided that 0, 7 is kind of our middle point. So that middle point doesn't always have to be 0. It could be out here. And we need to give 2 points to the left of that. So someone give me an ordered pair over here, the 2, 1. Bless you. Are we struggling with this step? I'm looking at the table. Okay? Are you looking at the table? Are you looking at anything? Okay, then tell me on your table, give me 2 values to the left, Brandon. He would not lie. -8 worked out? Okay, and what did you get for -8? 5. What else? We need one more that way. Something smaller. So -1 should have also worked out, and that would have given you 6. Okay, and then we need 2 on the other side. I think 1 works out, gives you 8. Well, 1 gave us 8. 8 doesn't work out? 8, 9. Do we know where I'm talking about on the table? Because if you can't find the table, and I'm finding that there's some of you that are not on this table. We're doing on the graph. Hit the trace button if you want to do that. Yep, I'm going to click over. See, it's going to give you those values. But I want you guys to be in the table. I feel like I need to show you. So we're going to go to y equals, and it was third root of x plus 7. Oh, get out of the radical. And then here I'm going to go hit the blue button and table. How do I see more here? Oh, that's not what I wanted. Okay, so when I'm looking at this, yeah, the graph can kind of tell you what's going on and it's asking you to graph it, but really the table is where I want to go. Because here on the table, I found my 0, 7, and then I need to get a point there, and any one that has decimal, I'm going to ignore. Okay, so I go all the way down. I see I got 1 on each side very easily. What I need to do is I need to go up more until I find there's 1, -8, 5. Ignore this second one here. -8, 5 worked, and then I just got to find 1 on the other side. Okay. Any questions on that? It's clear as mud. Brandon, you got it now? You're the best. You're like my top 100 favorite student. But now I have 85 students this year. All right, so we'll stop there. Go ahead and try to tackle that homework. And then keep going. I have to put a grade in, so whatever your grade currently is in Desmond's and Alex is the grade that I'm putting, whether you get a failure notice or not. This grade is what determines how you do this 9 weeks, okay? There's nothing else. Some people asked me questions outside of class and said, how do I know what my grade is? Whatever's on Alex, it says your grade is what your grade is. If you like your grade, keep doing what you're doing. If you don't like it, make some changes, okay? The final exam is I'm going to just mirror whatever we get this 9 weeks. Unless you don't want to, I'll let you take the 270 test, and whatever percentage you get on the 270 test, we can call the final exam, if you want. So if you get an A this 9 weeks, you don't have to take the final exam. If you get a B this 9 weeks and you're happy, get a C this 9 weeks and you're happy, you don't have to take the final exam, okay? If you get a D and you want to see if you can get a better grade on the final exam, we'll give you the 270 test, okay? Just so we're clear, the agreement with Columbus State is that if you don't finish blue, that's the first class you would take when you get there, unless it's not required for your program, okay? Which it's kind of the case for a lot of people. Any questions? I don't think I created it. I just didn't have time this morning. Yeah, I'll create it here in about 5 seconds.